Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have been studying the three-dimensional objects. We have recently looked at a cube and a rectangular prism. Now you'll notice today these are not three-dimensional objects, these are two-dimensional objects. Our next three-dimensional object we need to study is a triangular prism. But I feel like we need to do a little review of triangles before we can study a triangular prism. Especially since last year, many kids in grade 7 might not have gotten a chance to talk much about triangles. So I want to, in this lesson today, talk about triangles and then look at calculating the area of a triangle. Now you're going to notice on this page, there are not triangles. We have a rectangle and we have a parallelogram. Now I want to talk about these first because they relate to triangles. So a triangle is half of a rectangle. If you look at the diagonal, one of the diagonals of a rectangle, if I do this, go from one corner of the rectangle to the other, you'll notice I get two triangles there. In fact, I get two right triangles, two 90-degree triangles, which is something we studied a lot this year in grade 8. So there's two triangles there. There's one here and one here. They're both equal sized triangles. So what you can say here, based on that, a triangle is half of a rectangle. And we already know that the area of a rectangle is length times width, or A equals L times W. Now this shape over here is something you might have studied in grade 7 as well. It's a parallelogram. It's very much like a rectangle, except its opposite sides are parallel. They run in the same direction. So this side is parallel to this side is parallel to this side. Something we want to talk about in a parallelogram is because the shape is shaped like that, to measure the height of a parallelogram, this dotted line that's an imaginary line, you have to measure straight up and down from one vertex down to the base of that parallelogram, and that would be the measurement of the height of that parallelogram. This here is just indicating that that dotted line is a very straight line that's at a 90-degree angle. Remember, that's the symbol for 90 degrees. So this distance here we would call the height of the parallelogram, and that height is always measured directly from the base of the parallelogram, which is the bottom. And you'll notice here that there's also two triangles in this parallelogram. If we go from one corner to the other, we get two equal-sized triangles. There's one there and one there. They're both exactly the same size. So once again, we can say a triangle is half a parallelogram, a triangle is half a rectangle. Now, when we're calculating the area of a parallelogram, area is the base times the height for a parallelogram. So it's very much like the rectangle, except we do the base multiplied by that straight up and down distance called the height. So on this page, we've just established that in a rectangle, there are two equal-sized triangles. In a parallelogram, there are two equal-sized triangles. So that's how we develop the math equation for the area of a triangle, knowing that basically a triangle is half of a rectangle and a triangle is half of a parallelogram. Since the triangle is half the size of the rectangle, the area is half the size as well. The math equation to calculate the area of a triangle is area equals base times height divided by 2, or A equals B times H all divided by 2. Basically, we base that math equation off the idea that the area of a parallelogram is the base times the height. So the area of a triangle, since a triangle is half of a parallelogram, the area of a triangle is the base times the height divided by 2. That's the math equation we use to calculate the area of a triangle. So let's use that to calculate the area of a triangle. So here we have a triangle. Now there's three measurements on this triangle. There's this measurement down here That's the bottom. We call that the base. The base of this triangle is going to be 8 centimeters. And we have this distance as well. Now, this distance, since it's a dotted line, that means it's an imaginary line there. It's just an imaginary line drawn straight down from the top of this triangle to represent the height of the triangle. So the height of this triangle is 6 centimeters, because we always have to measure the height as a straight up and down distance. And we know this is a straight up and down distance because we have that 90-degree angle here. Now you also have another distance. That distance is 7.7 centimeters. That's measuring one of the sides of the triangle, but that's not the height, right? You would never measure the height of something as a diagonal distance, right? You would never measure your own height diagonally. You would always measure it straight up and down. So this diagonal height just represents the measurement of that line. So on this triangle, the base is 8 centimeters, the height is 6 centimeters. To calculate the surface area of this triangle, you do the math equation, A equals B times H, and divided by 2. Substitute in those values. A equals, the base is 8 times 6 divided by 2. Now we could do 8 times 6 is 48, divide by 2 is 24, or we could do this. We could go, you know what? I know that 6 divided by 2 is 3, and 8 times 3 is 24. Or I could do this. I could do 8 divided by 2 is 4, and 4 times 6 is 24. So either way we slice it up, we're going to get 24. Many different ways we could do it. So I'll do it the traditional way here. 8 times 6 is 48. Divide by 2, and area equals 24 centimeters squared. That is the total area covering this entire triangle. So calculating the area of a triangle, base times height divided by 2. All right, let's look at another one. This is a right triangle, right? And we've looked at these already this year when we studied the Pythagorean theorem, right? We know that a squared, one leg squared, plus the other leg squared equals this side, which we call the hypotenuse squared. We did that earlier in the year. So 14 squared plus 12 squared will equal 18.4 squared. Now, what we want to get is the area of this thing. Now, in the last one, we had this imaginary dotted line measuring the height of the triangle. We don't need that in this one because this leg right here on the triangle, since it's a straight up and down line, and we know it's straight up and down because it comes at the bottom of this triangle at a 90-degree angle, we know this is the height. So the height of this triangle, 14 is the height, 14 centimeters, and the base is 12 centimeters. And in this right here, the hypotenuse is not the base or the height, right? The hypotenuse, you would never measure the height of something by a diagonal line. So our height is 14 centimeters, our base is 12 centimeters. To calculate the area of this triangle, we do A equals base times height, divide by 2. A equals 12 times 14, divide by 2. And you know what I'm going to do here? I'm going to do area equals, I'm going to do 14 divided by 2 gives 7. And I'm going to do 12 times 7. Well, I know 10 times 7 is 70, and 2 times 7 is 14. So that's going to be 84 centimeters squared for the area of that triangle. And that's how we calculate the area of a triangle. And then this allows us to calculate the area of more complicated shapes. So let's say I had a shape that looks like this. Ooh, it looks cool. It looks like some sort of fast-moving land speeder or spaceship. Ooh, looks exciting. So what we have here is we have a triangle and we have a rectangle. You just have to picture it. If I did this, you can see we have a triangle, right? Now, this distance, since this distance over here is 3.6 centimeters, that means this distance will have to be 3.6 centimeters. Now, this entire distance is 8.4 centimeters. This distance is 6.2 centimeters. So if we take this entire thing and subtract away this, we're going to get this distance for the triangle. So I'm going to take my distance, 8.4 minus 6.2, and I get 2.2 centimeters. So I'm going to say here that this distance is 2.2 centimeters, because right here, 6.2 plus 2.2 would give this entire distance of 8.4. So now I have a rectangle and I have a triangle. Let's calculate the area of the rectangle first. It's nice to label things. Now we know area of a rectangle is length times width. Area of a rectangle is 6.2 on this one times 3.6. I'm going to use technology for this one. So 6.2 times 3.6, and I get 22 and 32 hundredths centimeters squared for the rectangle part. Now for the triangle. The triangle is area equals base times height divided by 2. So the base of this rectangle is 2.2. The height is 3.6. So area equals 2.2 times 3.6 divided by 2. I'm going to use a little technology for this. 2.2 times 3.6 gives area equals 7.92, but that's still divided by 2, right? So when I work that out, I get 3.96 centimeters squared. And then I can do my total. I have to add up the rectangle and add up the triangle. So I'll label this total. The total of the rectangle was 22.32, and the total of the triangle was 3.96. We'll add those up. That's 8, 12, carry the 1, there's a decimal there. 3 plus 2 plus 1 is 6, and 2. And that's centimeters squared. So the total of that shape, using the area of a rectangle, which we already know, and the area of a triangle, is 26.28 centimeters squared. So I'm going to give you a couple questions today to practice calculating the area of a triangle, and then we'll be able to use that knowledge to calculate the surface area of triangular prisms the next day. I hope that helps. That's all for now. Flexing Teacher Weber, out.